Hey everybody, this week I wanted to talk about the solar math problem. Now you might wonder what that is. When you set up your solar array, you are trying to feed your internal systems, right? You want to make sure that your battery backup or whatever you're using for internally has power coming in. Being in the Northeast, we have winter conditions we have to account for. They include snow, and like everywhere else on the northern part of the continent, we have to worry about the fact that there's less light, right? Sunrise, sunset, much closer together than they are in the summer. So this is where it leads to the math problem. If I have a system that is sized correctly during the summer months, then come the winter months, I won't have as much power coming in. All right, I've got less time during the day that I can gather power, and winter has a tendency to be a little bit less sunny than other times of the year. And of course, you've got to consider the fact that you've got snow on the panels, or could have snow on the panels. The flip side of that in the winter months is the fact that the panels don't heat up, and all solar panels start to lose efficiency when they get hot. So we get a benefit there, but we've got less light to deal with, so it's an overall negative. If you look at what you've got for winter and scale your panels correctly for winter, then come summer, you're going to have a lot more power coming in than you can use. So the math problem becomes, what do you do with that excess? Let's say you've got everything set up so that you can completely charge your system every day during the winter, or most days during the winter when you have sun. That requires a certain number of panels, right? Because you probably won't be getting in the same number of watts per panel that you got during the summer. I'll give you an example. During the summer, I had my 4 panels out there, and I could get over 400 watts of power coming in off of those 4 panels. Now that I've got the 6 panels up there, I'm getting about 300 watts. So I'm getting about 50% on a good sunny day. And obviously less hours during the day. So the watts that I'm hitting peak, about 300, 50% of the panels, let's say, is for less time during the day. So remember, the watts don't matter until you hit that first hour, right? It's watt hours. So I have to have 300 watts coming in for an hour. But let's say that the only difference between the summer and the winter is that 50%. We'll start with that part. So if I want to get that same 600 watts that I should be able to get during the summer, during the winter, I have to double the number of panels. Now I have a dozen panels, right? So I have 1.2 kilowatts worth of panels set up so that I can get my 600 watts per hour during the winter. Okay. Summer comes around. I now have 1.2 kilowatts worth of power coming in to my system on a longer time. Well, if my system was good at the 600 watts, what am I going to do with 1.2 kilowatts? I have more power coming into the system that it can't use, because it's already filled up. It only needed the 600 watts. It only needed half of that. In addition to that, it had more hours during the day to get power. So the way to handle that math problem is, if you've got a hybrid situation like I do, where some of the power is coming in off of the grid and some of the power is going to be coming from the solar array, then during the summer, I can use less electricity because I have all that extra power coming in. So I can shunt some of my stuff that I would normally use over to the solar array and just run it from there. Whereas in the winter, I'm going to have to grab the power more from the grid. Now, it's easy to do if you've got things set up. For example, I have the EcoFlow units. EcoFlow units can pull power from the grid and from the solar array. So they'll take care of that piece for me. What I need to worry about on the other side of that is where the power goes. Now, I can't run the whole house off of it, so I wouldn't want the whole house there. And this is where the smart panels and other transfer type stuff come in place. However, typically those are used for power outages. What we're doing here is something a little bit different. We're not considering the power being out. We're just always going to run things off of battery. Now, that battery may recharge itself off of the grid or off of the solar, but the batteries themselves don't care where the power is coming from. They don't care where the power goes to. That's where you have to have a sub panel that allows you to disconnect it from the main grid and allow your battery to operate that panel. Now, the reason I say disconnect from the main grid is if you have an issue with your battery or you want to upgrade it or take it offline, by being able to switch that sub panel back over to using main grid again, you can just do that, take your unit out, do whatever you need to with the unit, swap it out with a different unit, do an upgrade. Anything that you want to do, you can do that and still have everything powered in the house, except for the little cutover time. And then when you put the battery back in, and you've got it hooked back into the panel, you can then switch the panel to use the battery's power as opposed to using the grid's power. So that's one way that you can handle having this extra power in the summer. What it means is that you'll be using less electricity, which means your bill will go down over the summer, but then go back up in the winter. Again, for me, it was good power basically from May to September or October. Might have started in April, but I only had the unit out there in May. So if you can get 6 months worth of lower electric, it'll balance out the 6 months of the normal electric. Because remember, we're not using more electricity during the winter. We're just using less electricity during the summer. Now that you might scratch your head and say, well, what's the difference? You're still using the same appliances. It's where your power is coming from. So while there are certain things that you may use in the summer, such as air conditioning, that might balance out what you use in the winter, heat. If you're not using those types of things in the summer, then your power usage is lower than it would normally be in the winter anyway. And you're just taking a little bit more away from that. So depending on how your billing goes, you will see a dip in the summer and a rise in the winter, and dip in the summer and a rise in the winter. And it'll just continue that way. Unless you have a panel that is your solar array is so big that you don't have to worry about any grid power during the summer or during the winter. You can just run completely off of your solar array. Then that means that you have extra power in the summer that you can use, which, if you wanted to put an air conditioner in, for example, or add to your home some air filtration systems, you could run those off of that extra power that you've got coming in. you then have some options over the summer that you didn't have before, because you're going to have a huge amount of extra power coming in this case, about 50% more power during the summer than you had available during the winter. And yet that would still allow you to keep everything charged up during the winter. Again, it's a math problem depending on what your goal is. If your goal is during the winter to just keep the batteries topped off so that you can worry if you don't have to worry if the power goes out, that's one set of mathematical equations, right? I just want to keep them topped off. They're not being used during the winter. Therefore, I only have to have so much power coming in. That still may mean that you have more power coming in the summer that you can then use for other things, but less because you're not using the stuff over the winter. And again, you're just balancing out you start off with what your goal is. And if your goal is to be as far off the grid as you can be, then having it oversized for the summer is fine, because you'll actually be using a lot less power because you've got it oversized, and then you won't have to worry about it, and your bill will be lower over the summer. Now, some places did allow you to sell electricity back to the grid, and some places are looking to tap into your local storage should power go out and things. So there are other options that you can get to try to make money with any extra power that you've got or any extra storage that you may have added to your system. But just for normal day-to-day use, just think about what it is that you need to use in the winter, if you want to take any of that off grid or not. And if not, then all you have to do is keep your batteries topped up, and you probably have that with a normal solar array, which will give you less electricity to play with in the summer. But again, it's what your overall goal is. If all you want is a system there that's going to just keep the lights on should the power go out, then you just need to keep it topped off at all times. And over the summer, you'll have extra power that you're not using. So that's what I got for you guys this week. Just a little bit of solar math problems, and I will talk to you all next week.